Hello again everybody and welcome back. In this video we're going to install TensorFlow on Windows, and then we're going to take a look at a first kind of handful of programs using TensorFlow to get, hopefully for everybody else out there that hasn't really used TensorFlow before or doesn't maybe have a working comfort level yet, to kind of get you up to speed on the basics. So let's go ahead and dive right in. So I'm going to link this in the description below, but just in case you like to get to this repository without the link, we can simply type git hub GitHub microcontrollers and more, and there we go. And then we're going to go here, and then we're going to go to repositories, and then we're going to look for this here, TensorFlow Tut1 installation and first progs, and then we're going to go ahead and clone this. So let's see here. So we're going to, in my case, I'm going to clone this to the documents directory. You can clone to whichever location you prefer. So I'm going to jump into any of these here to grab this path. So C, users, username, and documents. So we're going to cd to that location. Then we're going to do git clone, and then we're going to go to clone or download, and then we're going to copy this here. And so there's our two commands we're going to execute. So let's go ahead. There's one of two, and there's two of two, and this is a pretty small repository, so this shouldn't take too long at all. And there we go, it's already done. So as we get into the repository here, we're going to find, let's see here, documents, TensorFlow Tut1 installation and first progs. There we go. So the documentation for this, I've got a docx Word document and then a PDF as well. So you can view either one. If you don't have Word, obviously you want to view the PDF one. I'm probably going to go through the docx one here today, just in case I find a few minor continuing touch-ups as I go. Still kind of editing these documents a little bit and making some minor touch-up to these Python scripts. So in that repository I had up just a moment ago, if you find any typos or minor bugs, go ahead and file an issue, and I will definitely keep an eye on the issues and make the applicable corrections. So let's get right into it. So it is possible to install multiple versions of Python in Windows, but that adds some complications. For somebody that's a Python expert and would like to go that direction, feel free, but since that adds more steps in this tutorial, I'm not going to cover it. So the first step I'm going to suggest is that if you have any versions of Python prior to 3.6, go ahead and uninstall them now, and then check your path variable for any references to those, and go ahead and remove those. And let's see, so to check your path, you can simply bring up a command prompt here and type set, and then you're going to want to check your path here for any previous to Python 3.6 references, and go ahead and remove those and then reboot. So then we're going to install Python 3.6 or later. Currently I believe 3.6 is the most recent version as of when I'm making this here. Let's see, so Python, I think they're up to 3.6.4 now, or 3.6.5, so 3.6.4 is still the most current. There we go. So to install Python, you're going to simply go to python.org as I just demonstrated there, and then you're going to download Python 3.6. Whatever the latest version is, and go ahead and install that. I'm not going to go through that. It's pretty intuitive. I don't think that's necessary. The one thing I will mention is when you're asked, choose to add the Python path for all users. And then after that, we're going to install the necessary packages via pip. So for those not familiar with Python, pip is the Python installer package. So if you've used apt-get packages with Linux, or if you've used NuGet packages with Windows in Visual Studio, pip is kind of the Python equivalent to those. So we're going to go ahead and bring up a command prompt now to install Python packages with pip. You need to have an administrative command prompt. I should definitely mention that. So for example, if you go down here, you can type cmd. Don't left click on command prompt, but rather right click on it and then choose run as administrator, or you can pin it to start. Right now it says unpin to start because I already have it pinned to start, but if it's not pinned to start for you yet, then pin to start will be an option. So then you can simply right click on command prompt here and then go to more and then run as administrator. And it just asks me, do you want to allow this app to make changes to your device? I don't know if that shows on the screen recording or not, but in any case, when you bring up a command prompt, you can verify it's an administrative command prompt because it should say administrator command prompt at the top here. rather than saying just command prompt, and then it will say C Windows System 32 rather than going to your user home directory. So continuing on, using pip is pretty straightforward. By the way, you can type pip or pip3. In our case, just to make it 100% explicit that we're using Python 3, I'm going to type pip3. So if you type pip3 with no commands, that kind of gives you like a help menu basically. Lists what the commands are that you can use. So let's see, let's move this over here. And so here's some of the commands you can use here. So then we're going to do pip3 install -- upgrade TensorFlow, and that's going to install the latest version of TensorFlow, which I believe I already have, so it's simply going to say requirement already up to date. Okay, it's actually got a few additional packages that TensorFlow uses to install, so that's going to take just a moment. And while we're waiting for that, it didn't take long at all. Then we're going to install the most updated version of OpenCV if you don't already have the most updated version. We're actually not going to use OpenCV in this tutorial, but we will definitely use it in the next two tutorials where we're going to do a walkthrough on TensorFlow object detection. On TensorFlow, rather, the second tutorial will be classification, and then the third tutorial will be object detection. And we're going to use OpenCV in those, so we're going to go ahead and install that there. So I already had the most up-to-date here, so it simply said requirement already up to date. So just a few kind of final thoughts before moving on to the next step. If you type, or copy and paste in this case, pip3 list, then it will give you a list of all the packages you have installed and the versions as well. So probably a good idea to verify at this point you have OpenCV at least 3.4 and then TensorFlow at least 1.6. And then the way that pip works, the Python installer package works, is it downloads the dependencies for you as you go. So for example, TensorBoard was installed with TensorFlow automatically. So continuing on, we're going to install a Python editor. Actually, I already did this. PyCharm is recommended. PyCharm has really good autocode complete and syntax highlighting, and it kind of, if there's something suspicious in your code, it'll underline it for you. So I really recommend PyCharm. Idle comes with the Python install, but honestly, PyCharm is a much more complete editor. It is a pretty weighty program. It does take a moment to kind of load and configure everything on startup each time, but I definitely feel the weight's worth it. So I don't think it's necessary to walk all the way through the install for that, but for anybody that's not familiar, let's see, PyCharm, PyCharm, and then you're simply going to go here, and the community version is free here, so you're going to choose download now. And then you would choose community download and pretty much follow all the default options from there. So then the next step is going to be clone the repository containing this document. I already showed how to do that at the beginning of the video. For anybody that's new to Git, I've got some step-by-step instructions worked out for you there. You can go ahead and follow that. And then we're going to get into the scripts. So the first one we're going to take a look at is add2numbers.py. So part of this tutorial, not sure how to explain this. The actual processing guts of TensorFlow are written in C++, but the most common interface for working with TensorFlow is Python. So this is kind of a necessary part of this video. I have to sort of explain a few basics about Python for somebody not familiar with Python if they're also getting into TensorFlow at the same time. So the first program we're going to look at does not use TensorFlow here, but rather it's this one here, add2numbers.py. This is about the most simple program I could possibly think of to add two numbers together in Python. So we're going to wait just a moment here while PyCharm loads for us. And then in the next program we're going to basically repeat the same functionality but using TensorFlow. And then in the third program we're going to repeat the functionality again but using TensorBoard, which in addition to TensorFlow, which will allow us to visualize our TensorFlow graph. So more on all that shortly. So let's go ahead and start this up. So in PyCharm, if you do Alt-Shift F10, this gives you this nice shortcut run menu here. So add two numbers, there we go. And you can look through the code here. I think it's pretty self-explanatory though. So enter num1, let's go with 4, enter num2, 3, and then 4 plus 3, of course, as we know, is 7. So we're all set there, and it's still doing a few updating tasks here. PyCharm is, so it's okay. We'll just let it finish there and then exit out. Alright, so now we're going to go to add two numbers via TensorFlow.py. And so this is basically going to do the same thing we just did, but it's going to declare two tensors, and then we're going to run a session and sum them. So if this is the first TensorFlow program that you've seen, this is actually probably worth a quick skim of the code here. So first we get the two numbers from the command line, just the same as the previous program. Then we establish two tensors here using the integer num1 and 2 that we read up here. We're going to declare tf.variable and then read that into our tensors here, num1 and num2. Then we're going to set up our graph here. So we're going to do tf.add num1 and num2, and then that gives us sum. And this next line here is worth mentioning. So we're going to print sum. And if you're not familiar with TensorFlow or other deep learning neural network environments, you might think that this would print whatever the sum of the two numbers is. It actually does not. It prints information about the tensor sum. And the reason for that is because we haven't actually ran our graph yet. So to do that, we're going to call tf.globalVariablesInitializer, and that's going to give us a global variables initializer, of course. And then finally we can run our session. So we're going to do with tf.session as ses, then we're going to do global variables initializer.run, and then we're going to do sum.eval. This is actually the line here that's going to perform the sum. And then that's going to assign the result into result, and then we're going to print result, and here's where we'll actually see the result. So let's go ahead and run that. And I figured this program was worth going through because pretty much every TensorFlow program out there is going to have kind of the same two basic sets of steps. First, you're going to set up a graph, and then you're going to run the graph. And this does take a little bit of getting used to if you're not used to deep learning or you haven't seen this type of thing before. So here we're going to do 4 and 3 again, same as before. So this line here, print sum, this is the result of that. So you'll notice it's not actually printing the sum, it's printing information about the tensor sum. That it has a shape of empty and then a D type of 32. And then down here when we print result, that shows us the actual result of 7. So if this is the first time you've seen something like this as far as deep learning, you may want to take a moment to just kind of stare at this code and absorb the concept, because you're going to see this again and again. So continuing on here, we're going to go on to the third script, add two numbers via TensorFlow TensorBoard. And this script is going to demonstrate a very nice utility that TensorFlow includes, TensorBoard, which allows us to visualize our graph. And in this case, the graph is going to be really simple because we simply have two numbers and then we're summing them. But in the case of a relatively elaborate graph, actually let's take a quick skim through the code before we run it. So these two lines here are the same. We have the same two imports at the top, import TensorFlow STF and import OS as well. And at this point there's some minor differences in the program. So variable, instead of simply having int num1 and leaving the name as the default, here we're specifying that the name is num1 and then the same thing for num2, but of course num2. And then when we establish the graph, we're going to add num1 and num2, and then we're also going to specify that the resulting tensor is going to be called sum. And then we're going to print sum, and once again this won't actually print the sum, it's going to print information about the tensor sum. And then from this point through, the program is the same until we get down to here. And here's where we're going to write out the TensorBoard information to file. So if we do tf.summary.filewriter, and then we're going to write it to the current working directory, so in other words, wherever the script is being ran from. So that instantiates FileWriter. Then we're going to add the sessions graph to FileWriter, and then we're going to close it. So let's go ahead and run this, and hopefully this will make some of the concepts from the previous script a little bit more concrete to anybody out there who's a TensorFlow beginner. So if we do 4 and 3, so once again this line that prints sum doesn't actually print the sum, it prints information about the tensor sum, whereas this line down here actually prints the resulting sum. And what running that script did for us is it's going to create this file right here, events.out.tfevents.these various numbers. And so how do we view this? Well, it's relatively straightforward. Fortunately, we're going to use a browser to do that. So we're going to enter the command at a command line, tensorboard -- log directory equals, and then wherever your repository location is. So for example, in my particular case, I would enter this. Obviously, in your case, you're going to have to change the username and or the path to wherever you wrote this file to. So we'll go ahead and bring bring up a command prompt, and this is actually going to serve a web page. So what we're going to do is we're going to copy this here, and then we're going to open up a browser and paste that in. And there's our graph. So as I was kind of mentioning earlier, this is not a very exciting graph because it's about the most simple TensorFlow program you could possibly have. But in the case of a relatively elaborate graph, this information here, how the nodes and edges and everything connect together, is extremely valuable and can help you kind of plot out a program or fine-tune something, maybe find a bug that you hadn't at first anticipated, etc. So definitely TensorBoard is worth much more of a look than this. There are many things, all kinds of statistics and such that you can get out of it, so we've only just begun to scratch the surface a little bit here, but I thought that was worth mentioning. So continuing on, let's take a quick look at the walkthrough document here, and I've spelled things out in a little bit more detail in the walkthrough document, so if any of this is unclear, please refer to that. But let's see. Okay, so the next two examples we're going to look at are going to be mnist softmax.py, and then we're going to take a look at mnist deep.py. So I'll kind of explain those a little bit as we load the first of those two up. So let's see here, mnist softmax.py. So this is both of these mnist softmax and mnist deep are scripts that use this mnist dataset, which is a sort of pre-assembled dataset that Google has come up with, and I believe it's short for Modified National Institute of Standards and Tests or something similar. Somebody in the comments is probably going to correct me on that, but in any case, what this data set allows us to do is it's a data set of, I believe it is 50,000 handwritten characters, and we can run some algorithms to test on those handwritten characters for testing classification. And this saves us some time as far as having to make our own data set. Unfortunately, I'm just going to quickly skim through these two examples because they don't actually show you how to work with your own data because you're using a pre-done data set. So in a sense that's a benefit, but in a sense it's not. So we'll just take a quick look at these, and then in the next two tutorials, the classification walkthrough and the object detection walkthrough, we're going to do everything setting up the data set using our own images ourselves from the beginning. So here is this input data. So if we do from tensorflow.examples.tutorials.mnist, this gives you this input data, and you can read that in simply by doing input data.read datasets. Now, well, actually, let's take a look at the next two functions that this mnist dataset uses here. So we have mnist later on here, then we're going to call mnist.train.nextBatch, and that's going to give us our batch x and y, and then we also have mnist.test.images and then mnist.test.labels. So these 4 lines, I guess that would be, where we read in the data set, and then this read datasets function gives us this mnist variable, and then where we do train.nextBatch, and that gives us the batch x and y, and then where we do mnist.test.images and mnist.test.labels to give us the images and labels. This pre-done dataset and the functions that come with it and properties that come with it, this is actually doing a lot for you behind the scenes. And that's what we're going to get to in the next two programs that we won't kind of get into more detail now, but at least I've introduced these programs to you. So this is a pretty straightforward linear regression model that's defined here. And then similar to the previous program, we're going to train and then we're going to test. And let's go ahead and run this and take a quick look at the output. And typically the output in this comes out to be low 90s%, like 91 to 92%, and it shouldn't take too long to run. And then in the next program, as long as we're waiting for this here, okay, there we are, 92.22%. That's a little bit higher than usual. So now we're going to jump on to the next program. So it's actually possible to do far better than that for classifying handwritten characters. This mnist dataset actually only uses the numbers 0 through 9. It doesn't include letters as well. So it's possible to do quite a bit better than 92%. And this script here, mnist deep, uses that same pre-done dataset, but uses a convolutional neural network rather than simple linear regression. And in my videos, I try to stick to implementation details, not branch off into theory too quickly. So I'm not going to get into the theory of convolutional neural networks. There are plenty more resources out there you can Google or YouTube search on to learn much more about that. So let's kind of jump through what the script does here. So after parsing some command line arguments, we have this tf.app.run, which takes us into main, which takes us up here. And then main calls these other functions. These four here are pretty short: conv2d, maxpool, weight variable, and bias variable. And this function up here, deep NN, that's of course short for deep neural network. This actually sets up the CNN itself and is a substantially longer function. So you can read through that as you feel best and refer to the TensorFlow website, as it does explain this function in much more detail than I'm going to get into here. And so then here's main, which essentially uses those other functions and then performs similar steps to what the previous script did, as far as there's a train step and then there's a test step. One change I did make from this, from the script on Google's website, and if you'd like the original script on Google's website, I linked to it up here. I believe the only change I made to this script was I changed the for I in range. I believe the default value on that was 200,000, and I changed it to 2,000 just to make it so that the script will run in a reasonable amount of time for us here today. So let's go ahead and fire that up. And it's going to jump into the training, and you're going to see that in a pretty short amount of time it's going to get at least into the 90s%, and then eventually it will typically get to 97 point something percent accuracy. So there we see step 0, it's at 8%. Step 100 is already up to 86%. And let's see, I believe it'll probably hit 90% within the next couple steps. Yeah, there we are. At step 200, it's already 90%. So at this point, I'm going to pause the recording and wait for the script to run, which will take on a moderate computer without a GPU, maybe in the neighborhood of 3, 4, 5 minutes. So it looks like our script is all done running here. So we got 97.7% accuracy, and that's typically about what the script does. So that's complete. We can close out of PyCharm. And let's see what we have remaining for this first walkthrough tutorial here. And let's see, just a moment here. Okay, so 2 more topics before we move on to the next video, which will be a walkthrough on classification. First, I'd like to offer just a few words here on how to write readable Python programs. So Python offers a lot of flexibility on where you can place your statements, as far as you can place statements outside of functions, and you can place main anywhere, etc. So for example, Python will let you do something like this: put statements here, which will run first, then define a function, which won't run the first time through because the parser won't run anything inside a function. Then if you put more statements here, those will get ran. Then you can put your function main here, and then more statements here, which again will be ran immediately because they're not part of a function. Then you can define another function which won't be ran immediately. Then you can put more statements that will be ran immediately. Then you can put if name equals main. So for those not familiar with Python, what if name equals main does is, if the current script that you're running is the one that you're running, as opposed to being, so in other words, if some script.py used another script as a library and that had if name equals main in it, that actually wouldn't run. But in this case, if we run some script.py directly, then if name equals main will run because that's the script that we're running. So I'm not sure I'm explaining that maybe as well as it could be, but go ahead, and if you Google on Python if name equals main, you can definitely get some, maybe a more thorough explanation of that, but I don't want to get hung up on that at this point in this tutorial. So in any case, what would happen if you actually executed this script is this statement would run, then this statement would run, then this statement would run, then this statement would run. Then you would get down here to if name equals main, which, when this is in here, would then take you up to main. So then this statement would run, then function A would be called, then function A would run, then these statements would be run, then you'd call function B, which then that would be ran. So this is really unfortunate that I guess it's a good thing that Python is flexible, but it's unfortunate that many people will actually use that flexibility to write a program like this, which obviously is not good. This is really unclear. The logic of the program doesn't flow well or make sense. So I really suggest please don't write Python programs like this. And I'm always surprised when I look at other people's Python programs how often people actually do write programs like this. So how I would suggest to do it is, at the top, it's okay to have some variables outside, some statements outside of any function that run first. So for example, if you have some module level variables, you might initialize that at the top, but try to keep those to an absolute minimum. and then put everything else, then have a function main next, and then put everything else inside other functions from there on as applicable. And then at the bottom, you're going to have your if name equals main. So then that's going to take you back up to main, and then main will run and then call the other functions sequentially. So this is a much better way to organize Python programs to keep things readable and the logic kind of clearly flowing from top to bottom. So I really suggest this format. So one final subject that I'll touch on before we get into classification in the next video is command line parameters, and specifically how TensorFlow Python scripts often use command line parameters. So we're going to open up an example here that demonstrates that. So let's see, command line params.py. So while that's opening, this is worth going over because it's extremely common on the TensorFlow GitHub repository. This is how Google writes. I don't know. I should say all the TensorFlow scripts that take command line parameters, but this is at least the format they follow for most of them. Is that let's see. This is going to take another second to open up here. We're going to go ahead and run this shortly. And I think it's probably, rather than trying to explain it, it's probably easiest to just show you the format. So basically, you're pretty much always going to have import TensorFlow as TF at the top, and PyCharm's still loading up here. Just a second. Yeah. So you're going to have this import statement, and then they'll have in the module level variable section, they'll have a variable called flags, all uppercase, and then you're going to have your if name equals main, which has argparse.argument parser. And then that parses in the arguments in this type of a format. So in this example here, I only have 3 arguments, but you will find scripts on the TensorFlow GitHub repository that sometimes have 20 or more current command line parameters. So you're going to name them each by doing -- and then the param name. And then typically there will be the type and the default value specified, and then also help, which can provide some information about the parameter. And then after you've set up each of the parameters one by one, then you're going to do parser.parseKnown args, which gives you, for anything that's successfully parsed, it will parse it into flags, and then anything that's unsuccessfully parsed, it's going to put it into unparsed. And then typically tf.app.run is called next, which takes you into main. And then in this case, we're simply printing out the contents of those 3 flags. So if we go ahead and run this from a command line, hopefully this will make a little bit more sense here. So if we, let's see here, if we cd to that directory, and then we do Python, and then that script name here, command line params, and there we go. So let's go ahead and bring up a command prompt. It does not have to be administrative, and we'll go ahead and enter those commands. So there's the first one, and there's the second one. And even this program takes a moment to run because it takes a moment to run this line here, import TensorFlow. But it shouldn't take too long for us. Let's give it just another moment here. And what should happen, because we didn't enter any values, is sure enough here. So we have param1 default value, param2 default value, and param3 default value. So the reason that these 3 statements printed that is because we did not pass in any command line parameters. So in the case of param1, 2, and 3, the default value is used, which we've set here to param1 default value, param2 default value, and param3 default value. So if we were to run this same script but with some command line parameters, so we'll use A, B, C, D, E, F, and X, Y, Z, for example. Now those 3 print statements should say, and there we go, A, B, C, D, E, F, and X, Y, Z. So at first this seems a little strange. When you look at a program that has many parameters here, 20 plus is not uncommon. Then it can be a little bit confusing to look at, so I figured I should do this simple example for anybody that hasn't seen this format before. Pretty much any time you see this flags module level variable, it's going to be used in the same way. So hopefully if you run into this looking at some TensorFlow scripts on the Google's TensorFlow repository, now you'll be a little bit more familiar with how these are typically read in. So that completes this tutorial, and in the next tutorial we're going to perform a walkthrough on image classification. Then in the 3rd tutorial we're going to perform object detection. So I'll see everybody in the next one.